Okay, continuing on with our bundle manager, it's time to take a look at the update method.
Right. Now, our update method can be really, really simple, or it can be not so simple. I'm going to show you the really, really simple way first, and then I'm going to show you the not so simple and explain why it's not so simple.
Okay.
So let's start off with void update. And then basically we need to check whether or not it's time to start up a code routine. We do that by saying, hey, is the current bundle equal to null? Or is the current bundle...
Huh?
Well, yeah. Reaper? Hello? Wow, I have no idea what happened there.
Chubby fingers, hello.
Yeah.
Or
current bundle is done. So either the current bundle is done loading or it's equal to null. If either of those cases are true and our bundled queue count, no, not contains, count. Wish this thing was psychic. I could just talk to it, but or think to it, have it code. But we need to check the bundle count. There is no point in queuing up the next one if there's nothing left to queue up. So, but that's kind of obvious. And let me fix this.
there we go.
And this. What was ReSharper thinking? And this one.
There we go.
Anything else?
No, that's good now.
Okay, so there's our if statement. Now, to get our next bundle, we say current bundle equals bundled queue DQ. So this will get our next one. Now, the simple way of doing this is basically start coroutine, and we say load bundle, and to that we pass in the current bundle. That's it. That's all we would normally do. So if you wanted to use it as is, you would basically send in your request bundle. The next update, if nothing is currently being processed, it will get queued up. It'll start a coroutine, and it'll wait until it's all done. Then once it's all done, it processes the next one in order until the queue runs out. The problem is we can't really make it that simple. I wish I could, but I had to add some extra complexity to deal with our train patch. Now, at some point, this will change. This is currently just R&D code, and I put it here because it was the fastest place to put it without having to deal with anything else. So we will change this at some point. But what this code's job is to do is to check the information or the request for this train patch. If it is a train patch, then it needs to check the location of that train patch and if that train patch is still visible to the camera. Because if it's visible to the camera, then I'm going to go ahead and load it. But if it's not visible to the camera, I'm going to skip it completely. So we need to check to see if this is in fact a train patch. To do that, we'll check its URL, and we'll check to see that it contains the word terrain patch. And just to make sure, I'm going to force this all to lower. That way I can compensate for anybody's decisions in casing. So if it's a terrain patch, we're going to do a whole bunch of stuff. Else, we're just going to do the normal load. Now this is where it gets a little bit complicated. We have to do a bunch of string manipulation to break apart the location of the patch based off of the URL. And then we need to do the calculations that we've been doing in a couple of the previous versions. Those calculations being checking the angle of the direction of the camera versus the location of the patch, and then check to see if it's within a visible range of the camera, and then checking the distance. And then once we've checked those two, we can make the determination of whether or not we're going to load this patch or if we're going to remove it from the overall queue. So let's start off by defining a variable called s. We're going to call up current bundle dot URL dot substring. We're going to start at the initial location, and we're going to go all the way to the index. So URL dot last index of, or last index of. Yeah, I could do index of. Either one doesn't matter. I'm going to just follow my code that I've got in my example, which is index of dot unity 3D.
Not quite a dot, but close.
Yeah, well, it's a droopy dot.
Gotcha.
All right, so that strips off the Unity 3D off of our URL. Then we're going to say s equals s dot substring current bundle dot URL dot last index of our slash, add one to that. So we're stripping off all of the pathing part of our URL, and then we're going to replace.
Replace?
Yeah, that's how you spell replace now.
Okie dokie.
So we're going to replace our terrain patch underscore. So we're going to strip that out. We're technically removing it. I was thinking removing it because that's what we're doing in typing, saying replace and thinking remove, hence typing remove. So that will take care of stripping out the terrain patch part of it. Now we need to break things apart based off of the underscore. So s dot split, and we're going to split based off of underscore. We can then get our offsets, or our offset, equal to new vector 2, and we are going to look for int dot parse tokens element 0 and int dot parse tokens 1, and I'm missing something inside of here. I think I got too many. Int parse vector. There it is. Okay, cool. All right, so this gives us our offset. Well, let me bring up one of these files real quick so we can see what's going on. If I go find one of our files, and I'll bring it over as soon as I find it. There we go. So inside of our patches, inside of zone, we can see we've got train patches. Our train patch has our keyword, then an underscore. What we're doing is we're taking the path, which is this big long path of, in my case, it looks like d:\projects, yada yada, all the way through. So what we're doing is we start off by stripping off the Unity 3D. Then we strip off everything to the point where we get to the train patch. Then we strip off the train patch and the underscore, leaving just the 0_0. We're splitting based off of that underscore, so we end up with 2 tokens. Element 0 is this first number, which is the X position of that patch, and element 1, which is the Y position of that patch. We then turn that into a vector 2 here, which then contains the offset of the patch that we're looking at. Once we have that, we can get our camera's rotation Y from camera.main.transform.rotation.Euler angles.y, multiply that by mathf Come on, mathf dot deg to rad to convert it to radians because we're going to need to do some trig functionality to it. We can then determine the camera forward, which is going to be a new vector 2. And to get our vector 2, we're going to use mathf.sign. That sign, not the other sign. Cam rotation y by mathf. Did it again. Dot cosine cam rotation y. So that gets our forward vector. From here on, we're not talking about deer here, forward. All right, from here we can do a check that says if vector 2 dot product of our cam forward and fob now. All right, cam forward, and we're going to take our offset minus our camera utilities dot get current patch. So we're going to figure out where our camera currently is, and we're going to subtract that from our position. That'll give us a direction to our patch. We can normalize that, and then we check to see if it's greater than 0.5, which was the number that we were playing with before. Way back when we were doing the initial test while loading patches. And from here, we'll do that check, and then I'm checking all my parentheses to make sure I've got them all. So that's a vector 2 dots. I'm missing one. Dot minus current normalized. There it is. That one. Okay. So that's our checking the patch to see if it's still visible to the camera. And then we need to do a distance check, which is going to be vector 2 dot distance, and we're going to check the different distance between our offset and our camera utilities dot get current patch. And we need to verify that that is less than equal to 0.8 f. Yep, it's a magic number, but it's a magic number with a reason. And I'll explain it in a little bit because it requires pictures. And vector 2 distance, close out. There we go. So that should fix that. All right, now I still have an error.
There you go.
There we go. I'll get it.
I have faith. I know you will.
I hate parentheses, especially when you have lots of them. They get hard to figure out. All right, now, where does this magic number come from? And how did I come up with that magic number? For this, we're going to be playing with Photoshop a little bit. Go ahead and open this up. And, have I mentioned how I hate my slow computer?
Yeah, it looks like it's running great to me.
Yeah. Knowing that I've got two computers that are a lot faster, it's kind of sad. All right. I'm going to go ahead and... How do I want to do this? I'll do it this way. All right. So I'm going to draw a box. It doesn't look like I've got snapping on. So view, snap. There we go. All right. Now we know, based off of everything that we've done up to now, that our patches are square. So we can assume, based off of the fact that they're square, that as long as I pick a number for one side, all the other sides are going to be the same number. So let's say I decide that I'm going to call this side 1. Let's see, here, an arrow. So I'm calling this bottom side has a length of 1. That means all of the sides have a length of 1. What I need to be able to figure out, though, is how big is this number right here? So how big can I get that number? Or how do I get that number? Basically, what is that? That Pythagorean?
The
Yeah.
Pythagorean theorem will take care of that. A squared
Right.
plus b squared equals c squared guy.
Right, which means that I can take this, square it, take this, square it, add them together, and then take the square root, and that gives me this number. So if I say 1 squared or plus 1 squared, so that's 1 plus 1 is 2, and I get my handy dandy calculator out, which is right here, and I go 2, and I want the square root of it, I end up with 1.414. Now, why does this even matter? Let's move this over here so I can select this and bring it back. All right. Now, the reason this matters is because this is a square, and let's say our camera was in the dead center of this thing, right here. So I'm going to go ahead and make a little circle right in the center. So, oh man, really? Fine. Here. I really do want a circle here. Just draw me a circle. Thank you. All right, so I wanted to turn off the grid. All right, so let's say our camera is here. And we need to use a check to determine whether or not we are close enough to this next edge. So the way I decided to do this was figure out the overall length, and then I could divide this line in half to give me the distance from the center to the farthest point I can possibly get in any square. And when I do that, I have to take this number, divide it by 2. Gives me 0.707. So I could use 0.707, but I decided to just add a little bit of extra, which is where the 0.8 comes from. So if I jump back over to code, where we've got this, I can have 0.707, but the problem that I found with just the 0.707, which was mathematically determined, it's not really a magic number, I added the 0.8 because as I was increasing the camera's run speed, the 707 wasn't giving me enough of a padding to make sure that those patches were being drawn. So I just bumped it up to 0.8, and then I was getting satisfactory results. Now, this is basically just to ensure that every patch that is within this distance is going to be loaded regardless of whether or not the camera is looking at it. That's the whole point of this, but I just wanted to explain where that magic number came from.
Now, I have a question for you.
Yes.
A very serious question. Instead of just playing student, this is me playing me. All right, everything that you've done up to this point with all of your R&D and the way that things are laid out are all based on patches being square. Now, in this new pipeline that you have put together, you've introduced the new element of being able to take your geometry, your OBJs, and bring them over into Maya to do manipulation with them. One of the things that you had said earlier is that we have to stipulate that the edges, two joining edges of two different patches, must remain together. We talked about the easier approach is just making it to where you're editing one patch at a time, and you are not allowed to touch the vertices on the
The
outlying
boundaries, right?
edges. That's right. But what if, and then we had talked about the possibility of creating a Maya plugin that would allow you to bring in a section or perhaps even a zone or subzone and go in there and use all of the tools to do more serious sculpting. What happens then when we do comply with keeping two boundary edges together with one another, but we break the square? Because
You break.
that looks like that'll break everything.
Yes, you would break the entire underlying premise of this system
Mm-hmm.
at that point. I don't mind if some vertices creep left or right,
Mm-hmm.
possibly, if we get into the point, because right now the system hasn't been designed with being able to displace vertices off the grid.
Mm-hmm.
So if we followed that rule and said, okay, you can manipulate all your vertices, but your boundary vertices have to stay aligned. That was with the premise
Okay.
of being in Y only.
Mm-hmm.
So you can't violate the grid rule. We had mentioned that there might be a possibility later on that we could look at dealing with displacing the vertices in X and Z,
Mm-hmm.
which would then allow for things like overhangs and cliffs and natural bridges and things of that nature.
Right.
That still would work, but in general, you don't want to go, oh, well, gee, I can take this one patch, stretch it all out, and make it 5 times the size of another patch, as
Right.
long as the vertice count
Doesn't
stays
change.
the same.
Right.
The problem with doing something like that is that this entire system and its entire way that patches are categorized, broken up in the zones, and loaded are based off of a grid type system.
Correct.
Meaning that it expects one patch to be in that space at any given time. Once you break that rule and you start futzing around with it too much, you're going to break the underlying system. So technically, as long as you had a patch that didn't exceed the size of 2 patches put together, it would probably still work, but then you're going to run into issues with determining the load stuff based off of this type of equation, which will also cause problems with how the colliders are being loaded. Because if you've got some patches that are smaller and some patches that are bigger,
Mm-hmm.
the ability for the patch to calculate when it needs to have a collider is also going to break.
Mm-hmm.
So it's not something that I would really recommend doing. This whole premise of the system is based off or
Sure.
based around the fact that we are constraining to a grid.
Sure.
There
So
are
if you want
limitations.
so if you wanted to make overhangs, you would have to stay within the boundaries.
Or you would have to limit the size of the overhang.
Which
You could put it on a boundary edge as long as you didn't go crazy with it and it was only a slight overhang along that edge and it was only one part of the edge. What I don't want to see is, well, here, let's use Photoshop. We've got a square here. If I were to take a brush and see if this is going to be big enough, and if we were to push some of the overhang vertices like this,
Mm-hmm.
in one section, but overall the entire patch is intact in a spacing,
Mm-hmm.
then I'm not so worried about this little bit of an
All right.
overhang.
Next question. Then within the boundary, what can we do?
Inside of this boundary,
Yeah.
anything you wanted to.
All right. That brings my next question up then. If we wanted that data to be put back into the data store,
We're going to have to write a re-importer, because what's going to end up happening is our exporter is going to be based off of our data storage system. That data storage system is getting its information from the train generator. The moment we take this out into a 3D program and resubmit it into the system,
mm-hmm.
we have to reprocess that information and feed it back into the data store so it has that information available. That information is going to have to be saved as a set of offsets. so apart from the original
Okay.
terrain generated system,
Okay.
because if we decide to reset and re-pull the information from the terrain generator, it's not going to know anything about the offsets, and then we'd have to pull that information, apply the offset vertex information to that terrain stuff to recreate what was done inside of an external modeler.
Okay.
So it requires a lot more complexity to do it, but it is still possible.
Okay. That's cool. I was just curious.
Yeah, no problem. That's a valid question. It was stuff that right now is, again, we're early R&D stages, and this is just theoretical thinking that I had. Is basically, if I wanted to do this, how would I go about it?
Hmm.
But yeah, slight modifications, anything inside of here. If you want to make it persistent and fed back into the data store, we have to write software to do it.
Okay.
We don't have that,
And
but
in
it
all
could be done.
honesty, I'm not worried about that anytime soon.
No,
Because
there's just so many other systems that need to be dealt
absolutely,
with.
once we get this terrain done and we're just happy with the way the terrain works, period,
Hmm.
then we can focus on those things much later down the road. But it's time for us to move into, well, how are we going to handle multiple layered textures and masking and geometry on our terrain for decorations, etc.
Right. And if you look at the vast majority of MMOs and even some of the non-MMO type games, they have height map
Sure.
based terrain, and they deal with overhangs through static meshes.
Hmm. Absolutely.
So, I, there's a possibility. This was just a theoretical line of thought. We probably won't ever even look at doing it and just use meshes, but it is a possibility that we could do it. We might visit it.
Sure,
Who
it's
knows?
just not, yeah, at this point in time, once we get done with your current pipeline, if it gives us what we think it's going to give us, I mean, in some of your early demos and what we're building towards now, looks like it's going to do the job nicely, then we can move on. And if that's something we want to revisit later, we can, but I'm just letting our viewers know it's not going to be later like, well, when this system gets done and the persistence gets done, we're going to revisit that. We're talking perhaps much later because we'll be to a point where the terrain system itself will have been created by Lee exactly the way I was wanting to see it, with a little give and take here and there, but something that provides the kind of worlds I was looking for. So I'll be happy and we'll move forward.
Right. And it's got to be a really important need to go into doing that and go, we just can't do this with static meshes. Seriously? Why not?
Yeah, exactly. But I just felt, one, it was a important question for me to ask, not just for students out there that may have been asking themselves, since we did, say, hey, you could take this into Maya, and you can.
Hmm.
Just keep in mind about all of these the edges and all. But the moment we start looking at taking the data back into the persistent system for working back with sculpting, etc., and then re-exporting again, then that gets a little bit more, it gets
Well, you're
more involved.
right. I'm looking at it as a one-way type pipeline
Yeah,
at right now. Is basically you start
exactly.
off with the train generation system. It figures out everything through a complex series of calculations. On top of that, that gets saved out to the data storage system. Then there's some back and forth with the sculpting system. I'm thinking the train exporter is a baking process. That's the point where you go, okay, I've done everything that I'm ever going to do with the train sculptor, and it's ready to be baked out. Once that's baked out, then you can take it into Maya and fine tune it. But once you've done that, the purpose of it wasn't really to be fed back in. Can be done, but that would require writing all those extra layers of programming like we talked about.
Right.
But it was designed or currently looked at as a one-way trip. Once you've exported it out, then that's it. It's like going, if you want to tweak it in Maya and then you decide, hey, I screwed up, I need to re-export it, you're going to lose everything you did in Maya or Max or whatever else.
Right.
So
Okay, good enough. All right, so my apologies. Didn't mean to take us off on a tangent, but it was something that I was indeed curious about as far as what you were thinking because we had not discussed this off camera to this extent.
Right.
All right, so continuing on.
Well,
Or is that it?
I think that's pretty much it. Let me jump back. So I got sidetracked. I think we were pretty much done with it, though. But let's see. Yeah, sort of. Nope, we're not done with it. So, because that's if we actually do it. But if we decide that we've made the determination, it's not visible and it's not really close to us, what are we going to do then? Well, we need to go into our train manager, which we don't have. So we're going to leave that part out, but we have to do something with the train manager. Okay, so we got to come back and do that, but we going to go ahead and set the current bundle equal to null. This will basically throw away the bundle and say, hey, we don't need it anymore. So go ahead and purge it out, and then the next update, it's going to come through and go, hey, my current bundle's null. I can go ahead and queue up the next one if there's one available.
Okay.
So that should be everything that we need to do with the bundle manager, though.
Awesome. So in the next video, we're going to be visiting Game Manager.
Game manager. Is that what I got on there? Yep, sure. We can do that.
Okay, awesome. Well, thank you very much, ladies and gentlemen, and we will see you guys in the next video.